Hello learners, welcome back into the new video where you'll be introduced into a new topic. This now is about sets. Right, this is following a previous topic which we discussed about the algebraic fractions. So I have all hope that you guys are revising the concept that we have discussed. So I encourage you to use the link down here and play all the videos that we have discussed, right, so that you should be able to remind yourself, and that more importantly to update your brain. Right, so today we are going to be introduced into a new topic about sets. Right, we define what sets are, looking at symbols in them, and then we'll proceed for discussion. It's a topic that we studied already in JCE, so we don't take it as difficult. It's just for, just like here now in MSc, what is added here, but rather it is the same content that we discuss in JCE. Right, now before I start defining what sets are, can I first of all introduce you into the objectives that will take us through in all the lessons, so that we have to meet the topic. Right, so in here, in the sets, after we have defined what a set is, you as students, you should be able to be in the position to know the following by the end of the topic. You should be able to describe the elements of sets, right, which are presented in the form of a set builder notation. You need to know how to list the elements of a set in the form of a builder notation, and then elements of the set in the form of the universal set, in the form of a complement of a set, what elements are attached to this type of a set, and again the union of a set, what elements are involved in the union of the set, and then lastly we'll look at the intersection of sets. So you should be able to describe elements of a set in the builder notation, universal set, complement of a set, union of a set, and the intersection of sets. Right, that's objective number one, describing of elements. The second objective will be drawing of Venn diagrams. You need to represent the sets in the form of Venn diagrams. So we'll be drawing diagrams where we'll be illustrating the union of two or three sets, and also drawing the Venn diagrams where we're going to illustrate the intersection of two or three sets. And lastly, we're going to be exposed to the real life type of problems. These are word problems that we need you at least to apply all the skills that we'll be going to discuss here in the sets, that can you be able to solve problems which are there in the real life situation. So we'll look at that. So how to solve that? We'll be able to use issues about the Venn diagrams. Right, so this is what we'll have. Now, before we proceed in the discussion, can we first have a definition of what set is or about, so that we should be able to follow what we are discussing here. We can't just talk of something which we don't know its meaning. Right, so what I'll do here, I'll define a set. After I've defined the set, then I'll take you into the symbols that are involved in the sets. Because in mathematics, we don't necessarily use the statements. Ours is to represent the statements in the form of what? Symbols. Right, without wasting time, a set is just a collection of objects, or call them as what? Members. Collection of objects. Some can define it as what? Members. Right. So if we talk of collection of objects, you can consider this situation here is just like now a group of things which are together. For example, if you talk of students in a class, Form 3 classroom, we have got students there, learners. Students in a room are collected together. Might that talk of the students, it means we talk of a group of people who are together. As such, we are going to consider a Form 3 as a set. The objects in this case, or members, are the students themselves. Another example we can have is just like a box of chalk. If a box of chalk is to be defined as a set, then it means a box itself have got some things which are together. in this case, we'll be talking of what? Chalk pieces, which are inside the chalk. So together, they form what? A set. Right, so many examples. Think about the mathematical instrument. Instrument. If maths instrument, it will be defined as a set. Then we'll be able to look at the what? The object that makes that mathematical instrument as a set. So in this case, we'll be listing objects like a ruler, you talk of a protractor, you talk of a pen, you talk of a pencil, and what have you. So together, these materials, they form what is known as the object. As such, the entire group is referred to as what? A set. In mathematical instrument, referred to a set because of the group of objects which are like example, ruler, protractor, pen, pencil, etc. Right, so by this, I think we are together, we understand what a set is. We'll be talking of a group of things. You can also talk of numbers, natural numbers. A group of natural numbers. That is also defined as a set. Right, so that's it about it. Now, can we now look and discuss some of the possible symbols that we are going to be exposed to, so that each time we talk of such statements represented with the symbols, we will not be in a position to write these statements as such. We will write the symbols. You should be able to know when you write that, that one means A, B, C. Right, so here the possible symbols in the sets that are worthy for our discussion are as follows. 1. This is the first symbol. Very important. When you look at this symbol simply means it's an element. Right. Remember, we have talked of a set just like a group of what? Objects. Like say, for example, mathematical instrument has got a ruler, a pencil, talk of what? A protractor. Right. So if I take a protractor from the mathematical instrument, it means that one is an object. That object is referred to as the element. So we talk of just the objects or members of a particular set. They are defined as what? Elements. Right. Elements are just objects or members of a particular set. I have got a mathematical instrument. I repeat that. Example, I take a protractor. Protractor is part and parcel of the mathematical instrument. So mathematical instrument is the set. It means that mathematical instrument is a set. So if I take that protractor, you say it's just like what? A member of that set. So what I would do there, I would like say a protractor is an element of maths what? Instrument. So instead of writing that is an element of, we use this symbol here. This simply means is an element of something that is part and parcel of the group of the collection of objects. Right. Secondly, this other symbol that is also very important in this case, that is this one. It's more like a U that is facing upwards like that. When we look at this one, in our case here, when we're discussing about sets, this symbol simply means the union. Union of sets, whereby we'll be having a situation like, say, one set represented by letter A, another set represented by letter B, and be writing statements like A, this symbol, then B. Since simply means A union B. What does this mean? This one means elements which are found in A and B. Talk of the elements which are found in A and B. So it's more like you combine the elements in A and B. Right. So we're going to look at this one later as we'll be discussing. But at the moment in time, let's try to understand. When we meet such symbol, this symbol simply means union of a set. Meaning that we talk of the combination of elements of given sets. They can be 10, they can be 3, they can be 4, things like that. Right. In the contrary, we have another symbol which is just like more like the opposite of this, which is this. Right. When we meet this symbol, in our discussion, try to understand that this symbol simply means the intersection of sets. Right. To mean what? You'll be given maybe a group of sets, like say groups of sets of numbers. And it might happen that you have got some elements which are found in all those sets, like say set A, set B, and set C. The elements which are found here, and there. There are some which will be common. Like here there can be a 2, here there can also be a 2, here there can also be a 2. Amongst the several elements which are found in those particular sets. So those ones are known as the common elements. So here when we look at this symbol, this means intersection talks of the elements which are common, found in all the sets which are under discussion. So this one is defined as intersection. To mean what? We talk of a set of common elements. But this one we talk of a set of what? Union. If you talk of a union, we talk of the combination of what? Elements of particular sets. Right. We will look at this one in the discussion and you'll understand it better when we get there. Another important symbol is a symbol that is defined like this. You can be given any set like A, and here on top there will be like an apostrophe, which is not an apostrophe, just like a line which has got a meaning in this case. Right. When you write this line here on top here, this simply means complement, right, of a set A or any other description of a set, because the set is defined by a particular letter. So this simply means all elements which are not found in this set. Right. It's just like a complement of a set, which simply means elements of a set which are not found in here. For example, if we can have maybe talk of a particular set, like say talk of this set A is defined by maybe talk of 1, 2, 3, 4. This set might be contained in another set. So you look at this set have got 1, 2, 3, 4. So now when you write something like this, a line on top, that simply means the complement of set A. What does that mean? It means the elements of a set which are not found in A. So like here, if you talk of 1, 2, 3, 4, these ones are found in A. But what is not found in A? So that means there is another set that we're going to discuss here that is related to this one. We'll be going to compare. This one has got this. But now, what is not found in here, it means we're going to observe in the other set. And that set is known as the universal set. So at this moment in time, try just to understand, say, when we write this, what does this mean? A line on top means complement of A, meaning to say all elements which are not found in a particular set. Right. So this time around, just get to know about this one to say, what does it mean? It means that a complement means to say elements which are not found in that particular set. Going further, you also be exposed to symbols such like this one here or this. Right. This, in our discussion, this one simply means the universal. Universal set, which can be represented by any of the two symbols. You can write this one or you can write that one. Right. So if you talk of the universal, it's more like men. So if you talk of a man, in this case, in our discussion, it simply means there's a certain set that also contains other sets, or a set out of which we can also compose some other sets. That it means universal. Right. And now the sets which can be made from that particular set, in our case, we define them as subsets. And they've got their own symbol that we'll be using each time we discuss about sets and look something like this. Right. So it's just like a subset and the universal set, they work hand, they are there, they are always related. They are related. You talk of a subset, you have to consider of you need to consider what? The universal set. If you talk of the universal set, that universal set produces the what? The subsets. So subsets are just part and parcel of the what? Main set, which called the what? The universal set. Right. Another symbol that we'll be discussing about is a symbol that carries lines like this one, or the same thing can be also be represented by colon, like that. So what does this or this mean? This and that mean the same here. In our discussion about sets, when you look at this and that, this simply means easy such that. So when you see me at one moment in time, I'm writing a colon like this one, or I write a line like that, try just to understand that this symbol simply means is such that. Right. And then finally, you need to be exposed to this other symbol, which can be like any other set that you are given, maybe set H, set A, set T, maybe T, and outside here there's a symbol which looks more like N, right? So it'd be just like that, this symbol, then open bracket H, where H simply means any given set. So when you look at this one simply means number of what? Elements, which are found in what? In H. So you see something that looks like N outside a particular set, like set H, and now it's closed up with a bracket like this. Try to understand that this is described as a number of elements in this H. So you as a student will just count how many elements are found in this set H. Just that. Right, so quickly try to just maybe play back a little bit this video and try just to be conversant with the symbol which I've just highlighted on the body here, right, because they are worth it for our discussion. So we now will be going, or we'll be learning through the discussion in the lessons. Please try just to be able to understand that that symbol simply means this, that symbol simply means that. Right, so that's it. Next is what? Having known the symbols and defined what a set is, we need then know how to present the element of sets. Right, how do we present the elements of a set? Right, so there are two possible ways how we can present the elements of a set. One is the direct one, where we just list the elements as such by description. Like say, for example, if here we can talk of the set of days of a week. We can represent that set of the days of a week by a particular letter, like say, for example, D. Right. So if I'm there going to list the elements of a set D, what I'll do here, I'll open up a curly bracket like this one. I think remember by form to work. Then I have to write all the names of the days of the week. Like what? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, then what? Sunday. In this case, it means D is really now defined as a set, because it's just like objects which are defined like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and what? And Sunday. Again, you can have again a list of the what? Say, talk of the numbers which are natural numbers, which are natural, by description, direct definition itself. Like say, for example, if you read the list of the numbers, or say talk of the elements of the numbers, which is represented by letter N, we may be in a position to write those numbers directly. Like say, for example, if we can talk of the natural numbers which are less than 80, then we'll be talking of the 1, 2, 3, 4, 5, 6, 7, and end at 7, because we talk of numbers which are less than what? Less than 8. So this is one way how we can present the elements of a set. Directly describe the set by a particular letter, and that letter should be a capital letter, such as I've just written here. D is a set of what? Days within the week, and here are the elements of the days within the week. And again here I've got N, capital N. N is what? N is just the natural numbers this is a list of natural numbers. What type of natural numbers are we just talking about here? Is it all? No, all natural numbers which are less than 8. So what are they? Here we have 1, 2, 3, 4, 5, 6, 7. Right. And this particular presentation is the one that we are already used up with, and we have been using it since JCE. But now here in Form 3, at least now advanced level, we have another way on how we can present the what? Elements of a set. Apart from discussing them like this directly, we have another way how we can present the elements of a set. Right, so what is this other way? Right, so this one is what we're going to discuss here right now. The second way is by the use of what we call it a set builder notation. Set builder notation. Right, so it means you can describe the elements of a set directly by just introducing the capital letter to describe the members themselves, and have the list individually written in the curly brackets like that. But apart from that, we are also talking of a set builder notation as another way of presenting the elements of a set. So let's just discuss a little bit about this way of presenting the sets. Right, so to define this one, we should not take it very special to say maybe there's something that is technical. No. It's just like a matter of now describing the members of a set where some symbols are being what? Are being used. Things like that. So here if we talk of set builder notation, we talk of just a mean of describing a set by using what? Symbols. Right. And here most of the times it is brief. You don't necessarily write all the elements. Sometimes you can have 100 elements. For the direct way, it doesn't make sense to write every element down. But now with a set builder notation, things becomes very brief. You don't write everything and you save time and also space. Right, so now let's discuss how is set builder notation being presented. Right, so from what I've said here, in the set builder notation, we're using the symbols. So first, I will need to discuss with you the symbols which are being used. Right, the most important symbol that we use here to define the set builder notation are the ones that I highlighted earlier when we were discussing about the what? Symbols. Right, here we have a line like this one, which is the same in meaning as a column like this one. Right, these two symbols represent easy search. That. Right, they help us at least to brief up the description of the elements. Say in case we have got a lot of elements to be defined with these two symbols in a set builder notation, it becomes very brief. Right, so let's see how are these symbols being used. Right, but now before we go into discussing how these symbols are used, let us also understand that here, apart from using the symbols of this line and the colon, we also use a certain variable of our choice. You choose a variable to define the elements of the set. Like say for example, you can choose X, like there we're talking of the days of the week. Instead of you say Monday, Tuesday, Wednesday, Thursday, and Friday, you just say let X be a day within a week. So we know that each time we talk of X in our discussion here, we understand that X represents what? A day in a week. It is a description that is defining a particular element as such. So more importantly, what I'm trying to say here in the set builder notation, there are symbols which are being used. One, this one is line, and this one is just a colon, and again a variable, say like X or any other what? Letter. So such symbols are the ones that are there describing the sets, the elements of the set. Right. For example, here we have got a set A which has been presented in the form of elements directly by the first method, like the one we have been doing in JCE. So we have got a set A whose values are 1, 2, 3, 4, 5, 6, 7, 8, 9. And these values, we know for sure are natural numbers, or one can call them as whole numbers. You can give description to them. Right. So here we are considering A as a set of natural numbers less than 10. What if now there are numbers which are less than 1,000? Numbers which are less than 1 million. Can you manage to write them down, all of them? That will take you a lot of time and needs a lot of space. But now if we said build a notation, what we're going to do with such list of values, you're just going to breathe up everything into this light up. Right. So now, having realized that A is a set of the natural numbers which are from 1 up to 9, we can understand that these numbers are really less than 10. So how do you write? Here, what you do in the set builder notation using the symbols which I've just highlighted, you're going to write A itself as a set and write it equal to, as I've indicated there, you open the bracket. You choose a variable. There I use X. So here I'll write X. So you'll be asking yourself, what is X? X is not appearing in the list here. So you'll be like, now what is X? So this X is a variable that is just like describing all that list. If there were maybe 1 million values, it means all those 1 million variables, okay, values will just be defined by what? A single value here. Right. So what do you say? X. Then here write a line as I've indicated there. Then here you also write X. And then you write X with a symbol, this one, and a 10 by that. And what do you say? Comma X, that is this, what I've already said, is an element of what? Natural numbers. Right. So what does this mean? For somebody who knows mathematics about this, know that n is a natural number, okay, and this is an element, but now X in our case has to be defined. So when you're going to look at this one, you are going to describe it down here to say A is a set of all elements X, of all element X, such that, this line means such that X is less than 10, where X itself is what? Natural number. You see? So just like variable X is defined here, what is X is n. Our n is natural number. But now, what are we talking about? X, which are natural numbers. We are not talking of every natural number here. We are just considering only those which are what? Less than 10. So if you are going to quickly look at this one here, or this one here, and this one, you find that this set here directly is just is being defined by this what? Simple notation. So if you look at the given set A, 1, 2, 3, 4, 5, 6, 7, 8, 9, where A is a set of natural numbers less than 10. So you find that the same thing, the whole this passage is just like briefed up into this manner. A is a set of all element X, where X okay, is such that X is less than 10, and where X is an element of what? Of n. And n itself is a natural number. As simple as that. But if you don't want maybe to use this what? Line here, what do? You can choose to use what? A colon. A colon and the line, they simply mean the same thing. Right. So please try to understand that the X here is representing the element, right? And the line here is representing an expression is such that. Right here is just in quality, it talks about the boundaries, to say here we're talking of everything that is less than a 10, and here this n is defining the meaning of X. X are natural numbers. Right. So this is what I had also for you on this other part here, to say when you see this or this one means such that. So verbalizing this one, we say A is a set of all elements X, such that X is what? A natural number. Right. So by that, I think now we can have lots of examples to define the same thing about the set builder notation. Like say for example here, I have got D is equal to D, here there's a colon, and D is going to be described here in this way. What does this mean? You also say D. Now instead of A, talk of now D is a set of all elements D, such that D is a day of a week. Instead of writing the days directly, Monday, Tuesday, Wednesday, Thursday, Friday, and all that. Again here, we have got another presentation of what? Elements. This is also a set builder notation. What does this one mean? And you can also be able to list up the elements of H in this case. Right. So what is here is just like H is what? Is a set of all elements. Right. What? P. Elements P. You can go by that one. Elements P. So we're going now there going to discuss P. What is P? Say P is such that. This one it means is such that P is what? A number that is in between -2 and 8. And this number is what? Is an integer. Right. So if somebody can ask you to list up the elements of H, you'll be able to see that that H is described by elements defined by P. A P is just bounded between -2 and 8. So it means you're going to talk of all the numbers which are above -2, which are a -1, talk of a 0, talk of a 1, 2, 3, 4, 5, 6, 7, like that. And these ones, they form a set H. If you are to write directly, you have this. So when you look at this presentation and this presentation, they talk of the same. Right. So at this moment in time, I'll just leave you just a small exercise that you can at least be able to play around and come up, maybe possibly the list of the elements of a particular set which are presented in the form of a set builder notation. Right. So please just go through that. This is another way how elements of a set can be presented. So every time we talk of a set builder notation, we talk of issues like this one. You talk of what is the symbols are being used, understand the symbols and how we define them out. This is the verb of which, this is the presentation of which, try to understand it out. Right, so on your own, can you try to work out on the following? Right, if I ask you to list out the elements of a set defined by this, how do you come up with this? More like a simple exercise. Let's say list all the elements or members of the given set. So here we have got set B, which is defined by a curly bracket. X, there's a line here. I will not describe it now. X is a factor of 16. B is equal to X is such that X is a factor of 16. So I want you to give me the list of elements directly of B. What could be the elements of B in that case? Right, by the same set builder discussion. So I think you can be able to go through this and come up with the list of the elements which are described by this set builder notation. Right, the moment can we halt here. We're going to meet in the next video. Right, please go back and revise it, the just simple discussion in this video, right, by the link down here, right, so that when we go into the next section, we should be able to follow each other. Thank you very much for being together.